All right, let's check out the next part of this, which is the example image analysis. And in this one, we can read in that runner.tiff just like we did in class. And I think in the last example. And we're going to get an imshow of S. And we can select for different colors. In this case, we can select this dot at 0, 0, 255. This one's 0, 150, 255, 255, 0, 150, using this data selection tool in the imshow. So say we wanted to extract the centroid of this dot, this blue dot, 0, 0, 255. We can come in and make a binary mask for it. And we can start off by separating the red, green, and blue channels of S, that our image, by taking every row, every column of the first matrix, second matrix, and third matrix corresponding to RGB channels. Right. Next, we can make a mask. In this case, we're going to make a matrix of ones with the same size as the red matrix, right? So if we run this, you can see that size red is equal to 792 by 612. So it's a vector 792 by 612. So if we wanted to look at what ones does, ones of 2 by 2, that gives us a 2 by 2 matrix of ones. So this function ones, whatever we input here, gives us a matrix of ones with that size. Okay. So in this case, we make the function size red. That gives us 792 by 612. That goes into the function spot of ones, and that'll output a red mask with the same size as our red image here, or the red channel of S. All right, so we do that same thing with green and blue, and that gives us a kind of a starting point for our mask. Now we can come in and we can select for anything that meets our criteria 0, 0, 255. And we do that by setting up this mask selection code block. Okay, so red mask is our ones right now. It's an array of ones with the same size as red. And we're going to say if red is greater than 0, then I don't want any of those pixels to go through into our mask. I want everything to be 0 if a red value is greater than 0, because I don't want any red, right? Similarly for green, I say I don't want any green. If this green channel is greater than 0, I want you to set all of the ones corresponding to these index locations equal to 0. For the blue mask, we want that to be 255. So then say anything that is not equal to 255 should be set to 0, right? So then we make a mask, which is the red mask times element multiplication of the green mask, element multiplication of the blue mask. In that way, we can make a mask that if we do an imshow, we get a white and black image of just that point that we wanted, right? We wanted this point, which is 0, 0, 255, and we extracted that as a white dot, right? Let's say we wanted a different one, show S. Let's say we want to select this one, 255, 200, 0. What do we do? Well, anything that is not equal to 255, not equal to 255, set it to 0. Green was 200, I believe, right? Look at it again. 255, 200, 0, right? So anything that is not equal to 200, set it to 0. In the blue, we don't want anything. So anything greater than 0 in the blue channel, right? In this blue matrix, that is a copy of the blue channel of S, right? Set it to 0. And we make a mask. We run it. We can image show that mask, and we can see that we've only selected the dot corresponding to that specific color combination. The next thing we can do is find the centroid of that white dot. So we're going to use this mask that we created. I'm going to use this command called region props. And if we want to look at what region props really does, you can do help. And it says that it takes in a binary image. So it measures image regions, properties of image regions. In this case, you can get a black and white image, right? And you can select the properties that you want to extract. So in this case, it says BW. BW just means black and white image, and it doesn't say it anywhere, but that's what it means. L means a labeled matrix. CC is a structured, connected. BW concomp is a different function in MATLAB that does it detects if things are connected, pixels are connected or not. Don't worry about it yet. But it tells you about these properties, but it doesn't say anything about these properties in the description of the function. We talk about the binary image BW, but we don't talk about properties. Those are here. All the properties we can extract from the image. So area, centroid, eccentricity, circularity, these things are all properties that we can input into the region props function. So in this case, I have input centroid into the region props for that mask that we created, which is, right, it's a white dot, right? So if we run this, we get W. You can see that if we click on W here, you can see that it returns a structured array with a variable centroid, and it has these values, 233, 141.93, right? So if we look over here, you can see that, right, basically the center of this is like 233, there we go. 137, well, I'm not really in the center of that white dot, so, right, so something like that. There's a centroid. So, to extract that value, because it's in this weird structured array, it's called struct, this thing, we got to come in and pull that centroid out. And we do that just by saying, this is W, and this is the output of region props. It's all your properties of that image. And you can ask for the centroid of W by saying W.centroid. So when you run that, let's take that off. Right, that's going to give you W, which is our centroid. And we can use that for things. In the homework, we're going to use that for looking at the vector direction from one point to another. So essentially you're going to do all these masking things, just basically copy the code that I gave you. It's going to be fairly easy, hopefully. And you're going to extract the centroid and then find an array, or find a vector direction. Okay. So, yeah, that's essentially it. If anyone has any questions after this tutorial, please come to my office hours and we can chat.